Optical illusions are like puzzles for our brains. They captivate us, challenge us, and often leave us in awe of their complexity. These illusions are not just simple tricks, they are a testament to the intricate workings of our visual and cognitive systems. They are images or designs that trick our eyes and make us see things that may not be real or are different from how they appear. These illusions can be found everywhere, from the natural world to the art created by human hands. They play with our perception, making us question what we see and how we interpret it. Our brains are constantly trying to make sense of the world around us, and sometimes they take shortcuts. These shortcuts are mental processes that help us quickly interpret the vast amount of information we receive every second. However, these shortcuts can sometimes lead to errors, creating the fascinating phenomena we know as optical illusions. These shortcuts are what make optical illusions possible. They exploit the brain's tendency to fill in gaps, recognize patterns, and make assumptions based on past experiences. This is why two people can look at the same illusion and see completely different things. Optical illusions can be fun and intriguing, but they also reveal a lot about how our brains work. They show us the incredible power and limitations of our perception. By studying these illusions, scientists can learn more about the brain's processing mechanisms and how we interpret the world around us. They show us that perception is not always reality, and that our brains are capable of creating their own interpretations of the world. This understanding can have profound implications, not just in science, but in art, design, and even everyday life. It reminds us to question our assumptions and to be open to new perspectives. From ancient times to the modern day, optical illusions have fascinated philosophers, artists, and scientists alike. Ancient Greeks and Romans used illusions in their art and architecture, while modern artists like M.C. Escher have taken these concepts to new heights. Scientists, too, have long been intrigued by how and why these illusions occur. They challenge our assumptions about what we see and remind us that our perception of the world is a complex and subjective experience. Each illusion is a window into the workings of the human mind, revealing the delicate balance between reality and perception. In this exploration of the world of optical illusions, we will delve into the science behind these visual tricks, examining how they exploit the intricacies of human perception. We will look at different types of illusions, from those found in nature to those created by artists, and explore the psychological and neurological mechanisms that make them possible. Join us as we unravel the mysteries of the mind's eye and uncover the secrets behind these captivating illusions. Through this journey, we hope to not only entertain but also to enlighten, offering a deeper understanding of the fascinating interplay between our eyes, our brains, and the world around us. One striking example of an optical illusion is the hidden word illusion. This fascinating phenomenon captivates both casual observers and scientists alike, as it challenges our understanding of perception and reality. Optical illusions like this one reveal the intricate workings of our visual system and the brain's role in interpreting the world around us. In this illusion, a word is cleverly concealed within an image, often camouflaged among a jumble of letters or patterns. The word might be hidden in such a way that it blends perfectly with the background, making it nearly impossible to spot at first glance. This clever concealment plays on our brain's tendency to overlook details that do not immediately stand out. At first glance, the word remains invisible, blending seamlessly into its surroundings. This initial invisibility is a testament to the brain's filtering mechanisms, which prioritize certain visual information over others. Our brains are constantly bombarded with a vast amount of sensory data, and to make sense of it all, they must filter out what seems irrelevant. However, when instructed to look for a specific word, viewers are often amazed to find that they can suddenly perceive it, seemingly materializing out of thin air. This sudden revelation is not just a trick of the eyes, but a demonstration of how our attention can be directed and focused. The brain's ability to shift its focus and bring hidden details to the forefront is truly remarkable. This phenomenon highlights the brain's remarkable ability to filter information and focus attention. It shows that our perception is not just a passive reception of visual stimuli, but an active process of selection and interpretation. The brain decides what to focus on and what to ignore, shaping our experience of reality in profound ways. When our brains are not actively searching for the hidden word, it remains hidden in plain sight. This selective attention is a survival mechanism, allowing us to concentrate on what is most important at any given moment. By filtering out unnecessary details, our brains help us navigate the world more efficiently. But when we direct our attention to the specific combination of letters, our brains can isolate them from the surrounding noise, bringing the hidden word into sharp focus. This ability to shift focus and detect hidden elements is a testament to the brain's adaptability and its capacity to learn and respond to new information. The hidden word illusion demonstrates that what we see is not always a direct reflection of reality. Our perception is a complex construction, influenced by various factors that shape how we interpret the world. This illusion serves as a reminder that our senses can be deceived and that our understanding of reality is often more subjective than we realize. Our perception is influenced by a complex interplay of factors, including attention, expectation, and prior knowledge. These elements work together to create our experience of the world, and they can sometimes lead us to see things that are not there, or miss things that are right in front of us. Our brains are constantly making predictions about the world around us based on past experiences, and these predictions can sometimes lead us astray, as in the case of optical illusions. By understanding these processes, we can gain a deeper appreciation for the complexity of perception and the incredible capabilities of the human brain. Another captivating illusion that demonstrates the subjective nature of perception is the spinning ballerina. This illusion features a silhouette of a ballerina, rotating gracefully on her toes. The fascinating aspect of this illusion lies in the fact that different observers may perceive her spinning in opposite directions. Some viewers will see her spinning clockwise, while others will perceive her spinning counterclockwise. Remarkably, it is even possible for the same individual to switch between perceiving her spinning in either direction. This illusion arises from the ambiguous nature of the two-dimensional image. Our brains are accustomed to interpreting three-dimensional objects in a three-dimensional world. When presented with a flat, two-dimensional representation, our brains attempt to reconstruct the missing depth information, leading to multiple possible interpretations. The spinning ballerina illusion highlights the active role our brains play in shaping our perception of the world. Rather than passively recording information from our senses, our brains actively construct our visual experience, filling in gaps and making inferences based on incomplete data. Optical illusions may seem like magical tricks, but they are firmly grounded in science. These fascinating phenomena have intrigued humans for centuries, captivating our imaginations and challenging our perceptions. From ancient Greek philosophers to modern-day neuroscientists, the study of optical illusions has provided valuable insights into the workings of the human mind and visual system. To understand how they work, we need to delve into the anatomy and physiology of the human visual system. The human eye is a complex organ that captures light and converts it into signals that the brain can interpret. This process involves multiple components working in harmony to create the images we see every day. Light enters the eye through the pupil and is focused by the lens onto the retina, a light-sensitive layer at the back of the eye. The retina is crucial for vision as it contains specialized cells that detect light and color. These cells are known as photoreceptors, and they play a vital role in how we perceive the world around us. The retina contains millions of photoreceptor cells called rods and cones, which convert light signals into electrical impulses that are transmitted to the brain via the optic nerve. Rods are responsible for vision in low light conditions, while cones are essential for detecting color and fine detail. Together, these photoreceptors enable us to see a wide range of colors and shades. The brain then processes these electrical signals, constructing our visual experience of the world. This process involves complex neural pathways and regions of the brain that work together to interpret the information received from the eyes. Our brains are incredibly efficient at making sense of visual data, but they are not infallible. Optical illusions exploit the way our brains process visual information, taking advantage of the assumptions and shortcuts our brains make to simplify complex scenes. These shortcuts, known as heuristics, help us navigate the world quickly and efficiently, but they can also lead to errors in perception. For example, Some illusions manipulate our perception of color and contrast. Our brains use contextual information to determine the color and brightness of objects, which can be influenced by surrounding colors and lighting conditions. This is why the same color can appear different depending on its context. Our brains tend to perceive colors and shades relative to their surroundings. This phenomenon is known as color constancy, and it helps us maintain a stable perception of objects under varying lighting conditions. However, it can also be the source of some striking optical illusions. An object that appears light gray against a dark background may appear much darker when placed against a light background, even though the object's actual color has not changed. This is just one example of how our visual system can be tricked by context and contrast, leading to fascinating and sometimes bewildering optical illusions.